And welcome to our new episode of Future Generation. Today we have a new topic for you, and it is farming or agriculture.
Agriculture is another word for farming. It includes both growing crops, harvesting crops, and raising animals. It provides food and raw materials for humans to survive.
It helps us provide food and fabric, cotton and wool, and other more.
Over a century, agriculture contributed to the rise of civilization. Before, people waste most of their time looking for food, hunting for wild animals, and gathering wild plants.
People learned how to grow cereal and root crops, and their lives depend on farming.
Today, people have gardens and little farms of their own, and some even grow their own fruits and vegetables. And some raise sheep, cows, and chickens.
Okay guys, what are you waiting for? Let's go do farming.
About 10,000 years ago, humans began to farm. This agricultural revolution was a turning point in our history that enabled people to settle, build, and create. In short, agriculture enabled the existence of civilization. Today, approximately 40% of our planet is farmland. Spread all over the world, these agricultural lands are the pieces to a global puzzle we are all facing. In the future, how can we feed every member of a growing population a healthy diet? Meeting this goal will require nothing short of a second agricultural revolution. The first agricultural revolution was characterized by expansion and exploitation, feeding people at the expense of forests, wildlife, and water, and destabilizing the climate in the process. That's not an option the next time around. Agriculture depends on a stable climate, with predictable seasons and weather patterns. This means we can't keep expanding our agricultural lands because doing so will undermine the environmental conditions that make agriculture possible in the first place. Instead, the next agricultural revolution will have to increase the output of our existing farmland for the long term, while protecting biodiversity, conserving water, and reducing pollution and greenhouse gas emissions. So what will the future farms look like? This drone is part of a fleet that monitors the crops below. The farm may look haphazard, but it's a delicately engineered use of the land that intertwines crops and livestock with wild habitats. Conventional farming methods cleared large swathes of land and planted them with a single crop, eradicating wildlife and emitting huge amounts of greenhouse gases in the process. This approach aims to correct that damage. Meanwhile, moving among the crops, teams of field robots apply fertilizer in targeted doses. Inside the soil, hundreds of sensors gather data on nutrients and water levels. This information reduces unnecessary water use and tells farmers where they should apply more and less fertilizer, instead of causing pollution by showering it across the whole farm. But the farms of the future won't be all sensors and robots. These technologies are designed to help us produce food in a way that works with the environment rather than against it, taking into account the nuances of local ecosystems. Lower-cost agricultural practices can also serve those same goals and are much more accessible to many farmers. In fact, many such practices are already in use today and stand to have an increasingly large impact as more farmers adopt them. In Costa Rica, farmers have intertwined farmland with tropical habitat so successfully that they've significantly contributed to doubling the country's forest cover. This provides food and habitat for wildlife, as well as natural pollination and pest control from the birds and insects these farms attract, producing food while restoring the planet.
Many think cooking as a chore, but it can be fun and a motivating hobby for any people. Think of it if you follow a recipe and it turns out exactly how you wanted it to.
You can share with friends, families, and more people you like. And also, you can build your confidence in the same time.
Enjoying the process of making a meal can teach you creativity and practical activities. You can watch some videos and learn different ways and types of cooking.
You can show your skills and learn also new skills by cooking. It's so fun for young age or young people.
Cooking can be a motivation on eating healthy, and you're gonna know what you're gonna put in your body and benefiting people in any age.
Okay guys, what are you waiting for? Let's go get our talent up by cooking.
Welcome to Cooking Land. Today we want to show you how to make a hamburger. The ingredients we need to make a hamburger: hamburger, burger buns, tomato, lettuce, cheese, onion, ketchup. Hamburgers are an American food. They're made with ground beef and are usually served with cheese, tomatoes, lettuce, and onion, although there are many different kinds. The beef provides proteins, the cheese fat, and the rest of the ingredients are rich in vitamins. Because of how they're made and the condiments, you should make burgers at home and with natural ingredients. One burger coming right up. If you want to really make it, ask an adult for help. Remember, never cook without an adult. It's more fun and safe. Slice the tomato. Slice the onion. Chop up the lettuce. Open the buns. Place a pan on the burner. Put oil in the pan. Fry the burger for 10 minutes. I'm starving. Place the buns on a plate. Place the burger on the bun. Lay a slice of cheese. Add the tomato. Add the lettuce. Add the onion. Add ketchup. What a delicious dish you made!
talk about a global problem, which is pollution.
Pollution is any harmful material in the environment. These harmful materials are called pollutants. They can be natural, such as volcanic ashes, or can be created by humans, such as trash, factories, runoff.
It damages the quality of air, water, and land, which are three major types of pollution. All living things depends on air and water.
Although cities are more polluted than the countryside, pollution can spread everywhere.
Government, environmental groups, and people are working to control pollution. Many governments made laws to stop releasing dangerous chemicals into the environment.
Some companies and people are trying to use less fossil fuels and instead use power from the sunlight, water, wind, and many other energy sources.
And of course, many communities use recycling to reduce pollution. Stay with us, friends, for some more.
There are several types of pollution that can have detrimental effects on the environment and human health. Here are some of the major types of pollution. Air pollution. This refers to the presence of harmful substances in the air, such as gases, particulate matter, and chemicals. Sources of air pollution include industrial emissions, vehicle exhaust, burning of fossil fuels, and agricultural activities. Air pollution can lead to respiratory problems, cardiovascular diseases, and environmental damage. Water pollution. Water pollution occurs when pollutants contaminate water bodies like rivers, lakes, oceans, and groundwater. It can be caused by industrial waste, sewer discharge, agricultural runoff, oil spills, and improper disposal of chemicals. Water pollution poses risk to aquatic life, compromises drinking water supplies, and disrupts ecosystems. Soil pollution. Soil pollution refers to the contamination of soil with harmful substances. It can result from improper waste disposal, use of pesticides and fertilizers, industrial activities, and mining. Soil pollution can degrade soil quality, affect plant growth, and harm organisms that rely on the soil ecosystem. Noise pollution. Noise pollution is excessive or disturbing noises that disrupt the environment and affects human health. Sources of noise pollution include traffic, construction sites, industrial activities, and loud music. Prolonged exposure to high levels of noise can lead to hearing loss, stress, sleep disturbances, and other health issues. Light pollution. Light pollution is the excessive or misdirected artificial light that affects the natural darkness of the night sky. It can be caused by street lights, outdoor lighting, and illuminated signs. Light pollution disrupts natural ecosystems, interferes with animal behavior and migration patterns, and can negatively impact human sleep patterns. Thermal pollution. Thermal pollution refers to the alteration of natural water temperatures in rivers, lakes, or oceans due to human activities. Discharge of heated water from industrial processes or power plants can disrupt aquatic ecosystems. Plastic pollution. Plastic pollution is the accumulation of plastic waste in the environment, particularly in oceans and waterways. It results from improper disposal and inefficient recycling of plastic products. Plastic pollution poses risk to marine life, birds, and other animals that can ingest or become entangled in plastic debris. Addressing and reducing pollution is crucial for the health and sustainability of our planet. Efforts such as adopting cleaner technologies, promoting renewable energy, improving waste management practices, and raising awareness about pollution's impact can help mitigate its adverse effects.
What is plastic? For most of our history, humans used stuff we found in nature to build the things we needed. But the invention of plastic roughly 100 years ago completely changed our world. Plastic is made from polymers, long, repeating chains of molecule groups. In nature, polymers exist everywhere. The walls of cells, silk, hair, insect carapaces, DNA. But it's also possible to create them. By breaking down crude oil into its components and rearranging them, we can form new synthetic polymers. Synthetic polymers have extraordinary traits. They are lightweight, durable, and can be molded into almost any shape. Not requiring time-consuming manual work, plastic can be easily mass-produced, and its raw materials are available in vast amounts and incredibly cheaply. And so the golden era of plastics began. Bakelite was used for mechanical parts, PVC for plumbing, electric gears and cases, acrylic as a shatter-resistant alternative to glass, and nylon for stockings and war equipment. Today, almost everything is at least partly made from plastic. Our clothes, phones, computers, furniture, appliances, houses and cars. Plastic has long ceased to be a revolutionary material. Instead, it became trash. Coffee cups, plastic bags, or stuff to wrap a banana. We don't think about this fact a lot. Plastic just appears and goes away. Unfortunately, it doesn't. Since synthetic polymers are so durable, plastic takes between 500 and 1,000 years to break down. But somehow, we collectively decided to use this super tough material for things meant to be thrown away. 40% of plastics are used for packaging. In the US, packaging makes up 1/3 of all the waste that is generated annually. Since its invention, we have produced about 8.3 billion metric tons of plastic, 335 million tons in 2016 alone. More than 6.3 billion metric tons of plastic have become waste since 1907. Piled up in one place, that makes a cube with a side length of 1.9 kilometers. So, what did we do with all this waste? 9% was recycled, 12% burned, but 79% of it is sticking around still. A lot ends up in the ocean, around 8 million tons a year. That's so much plastic that it will outweigh all the fish in the ocean by 2050. Because it's everywhere, marine animals keep getting trapped in plastic and swallowing it. In 2015 already, 90% of seabirds had eaten plastic. Many animals starve with stomachs full of indigestible trash. In 2018, a dead sperm whale washed up in Spain. He had eaten 32 kilos of plastic bags, nets, and a drum. While this is tragic and makes for great magazine covers, there's an even more widespread, invisible form of plastic. Microplastics. Microplastics are pieces smaller than 5 millimeters. Some of them are used in cosmetics or toothpaste, but most result from floating waste that is constantly exposed to UV radiation and crumbles into smaller and smaller pieces. 51 trillion such particles float in the ocean, where they are even more easily swallowed by all kinds of marine life. This has raised concerns among scientists, especially about health risks from the chemicals that are added to plastic. BPA, for example, makes plastic bottles transparent, but there's also evidence that it interferes with our hormonal system. DEHP makes plastics more flexible, but may cause cancer. It would be pretty bad if microplastics are toxic because they travel up the food chain. Zooplankton eat microplastic. Small fish eat zooplankton. So do oysters, crabs, and predatory fish. And they all land on our plate. Microplastics have been found in honey, in sea salt, in beer, in tap water, and in the household dust around us. 8 out of 10 babies and nearly all adults have measurable amounts of phthalates, a common plastic additive, in their bodies. And 93% of people have BPA in their urine. There is little science about this so far, and right now it's inconclusive. We need a lot more research before panic is justified. But it is safe to say that a lot of stuff happened that we didn't plan for, and we have lost control over plastic to a certain extent, which is kind of scary. But just to make sure, we should simply ban plastics, right? Unfortunately, it's a bit more complicated than that. Plastic pollution is not the only environmental challenge we face. Some of the substitutes we'd use for plastic have a higher environmental impact in other ways. For example, according to a recent study by the Danish government, making a single-use plastic bag requires so little energy and produces far lower carbon dioxide emissions compared to a reusable cotton bag that you need to use your cotton bag 7,100 times before it would have a lower impact on the environment than the plastic bag. We're left with a complex process of trade-offs. Everything has an impact somehow, and it's hard to find the right balance between them. Plastic also helps solve problems that we don't have very good answers for at the moment. Globally, 1/3 of all food that's produced is never eaten and ends up rotting away on landfills, where it produces methane. And the best way of preventing food from spoiling and avoiding unnecessary waste is still plastic packaging. It's also important to note where the vast majority of the world's plastic pollution is coming from right now. 90% of all plastic waste entering the ocean through rivers comes from just 10 rivers in Asia and Africa. The Yangtze in China alone flushes 1.5 million tons of plastic into the ocean each year. Countries like China, India, Algeria, or Indonesia industrialized at an impressive pace in the last few decades, transforming the lives of billions of people. This development was so fast that the garbage disposal infrastructure couldn't keep up with collecting and recycling all the new waste this brought. If politicians in Europe and the US want to address this issue, investing in infrastructure in developing countries is just as important as fighting plastic pollution at home, with campaigns and redesigning products to minimize unnecessary plastic production. The bottom line is, as long as we don't address plastic pollution from a global perspective, we will not solve it. Plastic pollution is a complicated problem. We found a magic material and we had a really good time with it. But we need to be careful, or just like Midas, we'll end up in a world that we didn't wish for.
Fossils are the trace and remains of plants and animals who lived long ago. They give scientists clues about the past, and they're important to paleontologists who study prehistoric life.
Most fossils are found that once lay underwater. They formed from the hard part, such as shells or bones.
The fossils are shaped into those in hard parts in rocks. Those fossils are called sedimentary rocks, such as shale, limestone, and sandstone.
Stay with us, friend, for some more.
Fossils are remnants or impressions of ancient organisms that are naturally preserved in stone. While there are hundreds of fossil types, they are often grouped into two major categories: body fossils, which are the preserved remains of plants and animals, and trace fossils, which are records of an animal's behavior, such as footprints. Together, they form the fossil record, a primary account that tells the story of life on Earth through stone. Fossilization, or the process of preserving organisms in stone, can occur in countless ways. These methods are largely grouped depending on whether the organisms are altered during the fossilization process. Fossilization that does not alter a specimen can help to preserve its original form and texture. Among many methods, this group includes organisms that have been frozen, preserved in tar pits, and mummified. One special case involves trapping organisms, oftentimes insects, in amber. This process begins when an organism is covered in tree sap. The sap, or resin, forms a protective seal around the entrapped organism. Over time, the soft resin hardens and turns into amber, with the organism suspended within. This process creates a biologically inert tomb for the organism, allowing its soft tissues to be remarkably preserved. Other fossilization methods change the specimen as it is being preserved. For instance, carbonization transforms soft tissues into thin black films of carbon. In fact, countless layers of carbonized plant material create a well-known fossil fuel: coal. But one of the most common types of fossilization that changes a specimen is called permineralization. Permineralization begins when minerals from water or the ground enter the pores of dead plant or animal material. Over time, the minerals attach themselves, clinging onto cellular walls and building a crystalline network in the empty cavities. This mineralization hardens the bone and turns it into stone, thereby preserving its original structure in fossil form. When conditions are right, fossilization can preserve crucial information about an organism. Permineralized wood often contains enough information to identify its tree genus and sometimes its species. Insects encased in amber have been so well preserved that their genetic material was extracted and partially sequenced. And footprints left behind by ancient hominins help paint a picture of what life was like for early human ancestors millions of years ago. With every fossil uncovered, the planet's ancient past becomes clearer, helping shape our understanding of our world today.